Next, coming back to sills. So remember, sills, they can be much, much thicker than dikes, but they can still be pretty long as well, right? So they can be tens of hundreds of kilometers long. And when a sill forms, so typically when we think of sills, we think of a just a flat sheet of magma that cools into a solid rock. But sills can also start to dome upwards as they push that rock above them up and away. And when this happens, when that sill turns more into a dome, we call it a laccolith. So why do you think a sill might start to dome upwards? Why does the magma push that rock up rather than continuing to extend laterally, right? Why do sills become domes rather than becoming just longer and longer and longer sills? While you ponder that, I'll show you a picture of this is a laccolith, a domed sill that again was formed beneath Earth's surface, but over time, the material on top of it was eroded away. It was uplifted to Earth's surface, and now we can actually see that dome on Earth's surface. So hopefully you've come up with your answer to why a sill might dome up into a laccolith. And it is because, again, thinking about the pressure, it's often the path of least resistance is up rather than out, right? Now, sills form by cracking the rock in front of them from the pressure that they're putting on the magmas, the pressure the magma is putting on the rock. So after they crack the rock, then the magma will flow into that crack. But typically, the crack extends farther than the magma, and it's because the magma is viscous, right? It's not super, super liquidy, so it's not going to fill in every tiny little piece of that crack. Often there's going to be some open room in front of it. And because the magma is viscous, the longer and longer and longer that sill gets, the harder and harder and harder it is to propagate forward. It's resisting that flow. And eventually, pushing the rocks above it up is going to be easier than forcing cracks outward. So, do you think that a sill is more likely to dome up into a laccolith near the surface of the Earth or at greater depth than the Earth? Remembering that the sill has to push up on the rocks above it, right? Knowing that, it makes sense that laccoliths typically form shallowly, right? The less rock on top, the easier it is for that sill to dome up. So laccoliths typically form within 3 kilometers of Earth's surface. The deeper they are, the more rock they have to lift. So if they are deeper, they're also probably larger, right? They have more pressure.